Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Unrevealed Arrows by Max Lamenis. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. The grid is partially covered with fog. Correctly placed digits will clear the fog around that cell. No guessing is required. So say you correctly place a digit here. That means it would clear the fog in that cell and in the surrounding cells around it, which is the 3x3 box that surrounds it. So basically, if you place the correct digit, it will clear the fog in the 3x3 space that is surrounding that correctly placed digit. And that's how Fog of War works. We have digits along an arrow must sum to the digit in that arrow's circle. So, for example, say this was an arrow going this way. Whoops, that's not good. Say this was an arrow going this way. That means the sum of these digits here must add up to what this digit is, assuming that this is the correct arrow, right? So say we had something like 1, 3, and 4 here. Then this would have to be 8. Because the digits on the arrow must sum to the digit that's in the circle of the arrow. And that's an example of how arrows work. And finally, we have digits on a black dot are in a 1 to 2 ratio. Not all dots are necessarily given. These are called black Kropke dots. What I would prefer is the rule to say black dots separate digits which must be in a 1 to 2 ratio. Or black dots separate digits where one must be double the other. I would prefer that. Anyways, for example, if this were, say, a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. In normal Sudoku, if you ever have three unique digits, which are in a, I prefer putting it this way. If you ever have a digit that is in a 1 to 2 ratio with two other unique digits, then that digit has to be 2 or 4. And the reason why you know that is what digits are in a 1 to 2 ratio with two other digits. 2 is in a 1 to 2 ratio with 1 and 2, and also 2 to 4. 4 is in a 1 to 2 ratio with 2 and 8, right? 2 and 4 is a 1 to 2 ratio, 4 and 8 is a 1 to 2 ratio. And those are the only two digits that satisfies. So you know anytime you have anytime you have a digit that's in a 1 to 2 ratio with two unique digits, it has to always be 2 or 4. Well, what happens if this is, so we see parts of an arrow here. And it has to be like I drew it when I was describing it. It has to be like this is essentially the arrow, or it's the other way around, right? It's here, which is basically the arrow here. Because you can't have, actually, I guess it could extend further. So you could have something like this. But at minimum, you're going to have 3 unique digits on the arrow, sum up to one other unique digit. What you can't have is something like 4 parts of the arrow here in the same box, and then it connects that way, right? Because then this is at minimum 1, 2, 3, 4, because there are 4 unique digits on this arrow, guaranteed. Yeah, and so that's what you're limited on. Well, if you have three cells which are in the same box, which are, I should say probably, which are unique, the minimum of that is 1, 2, and 3. But we have this black Kropke ratio here, right? anytime you have one digit that's in a 1 to 2 ratio with two other digits, in that scenario, you're always going to have 2 and 4 in those cells. So say you have 2, right? That's in a 1 to 2 ratio with 1, 2, and 2, 4. 4 is in a 1 to 2 ratio with 2 and 8. So you're guaranteed there has to be a 2 and a 4 in these 3 cells here, which means along this arrow, you cannot have a 2 or 4 available. Well, what's the minimum then for the digits along the arrow? It's 1, 3, and 5. And what does that add up to? 9, which is the largest digit. So this must be a combination of 1, 3, 5 adding up to 9, right? Because we cannot have 2 and 4 in that box anymore because they're next to one of the black crop key dots. Because of that, you know 1, 3, 5 has to be in along this arrow line, and 9 has to be either here or here. Well, that makes this a 1, 3, 5, 9 quadruplet in this box, which eliminates 1, 3, 5, 9 in the rest of the box. Therefore, this cannot be 2 with 1 and 4. It has to be 4 with 2 and 8. So this is 4, and this is 2 and 8. And we know this is the 9 here. So this is 9, which makes this 1, 3, and 5. And then this has to be 6 or 7 here. Okay, so this is guaranteed to be 6. Say this was the circle here on this arrow. This would be guaranteed to be 6, 1, 2, which would make that 9. That's fine. If 7, can 7 ever be the circle here? If you can't have 7 here with 1 and 2, because that adds up to 10. So one of these could be the head. In fact, actually, one of these has to be the head. Because if you try to extend it further here, the problem is there's too many digits, right? So say this was essentially this long, and then it extended to somewhere else as a head. This is at minimum 1 and 2, this is at minimum 6, and this is at minimum 1, which adds up to at least 10. Same if you go this way, right? If you try to extend it something like here to here, the problem is this is guaranteed to be 1 or 2, 6, and 1, again, which adds up to 10. So one of these is the head. If this is the head here, this has to be 8. If the head is here, this could be 8 or 9, but the problem is if this is a head, this is 6, 1, and 2 at minimum, which is 9. If this is the head here, this is 6, 1, and 1 at minimum, which is 8, which is the max this cell could be. Either way, you have to have a 6 here. So this must be 6 then. That's 7. We know this is the head. This must be 1 and 2 then as a pair, and this has to be 9 over here. So this is 9. We have a 1 to 2 ratio here, a 1 to 2 ratio here. This cannot be 6, so it's either 1, 2, 4, or 8 here. This cannot have a 4, so it's either 1, 2, or it's 3, 6 here. Does that tell us anything? I'm not really sure. This arrow cannot be just an arrow to a circle, so it must be at least 2 arrows here. Do we have anything else? So this is guaranteed, well, not guaranteed anything. Oh, it is guaranteed something. So we're guaranteed at least, this has to be 2 or 8 here. Because if it's 1, it can be 1, 2, 2, 4, or 4, 8, right? Those all contain 2 or 8. Which means in the rest of column 3, we cannot have 2 or 8. So the remaining digits in column 3 have to be 1, 3, 4, 5, or 7. That doesn't limit things very much. Oh, well, where is 7 in this box? that we just highlighted. Can't be here, can't be here, can't be here because it can't be in a 1 to 2 ratio with any other normal digit. So it must be here. So this is 7, which eliminates 7 in the rest of the column. Remaining digits in this box are 1, 2, 3, so 5 has to be somewhere here because it can't be any of these cells. That eliminates 5 in the rest of the column. So this cannot be 5 here. This becomes a 1, 3 pair, which eliminates 1 and 3 in the rest of the box and column. So this is 5. We know 1 and 3 can't be here. So that means 3 has to be in one of these boxes here. Well, can't be here because it can't be in a 3, 6 pair here because of the 6 in the column. So it must be here. So this is a 3, 6 pair. We know 1 also cannot appear in this cell, in these column. So where is it in this box? It has to be here, which makes this a 1, 2 pair. So this is 1, 2, which eliminates 2 here. So this is 8, which makes this 2. This can't be 1 anymore here. So this is 3, 4, 5 as a triplet. Also, in this box, the remaining digits are 4, 5, and 8. Well, 8 cannot be here to add up with another digit because there would be 4 or 5 to add up with it, and that's at least 12. So 8 has to be here, and this must be a 4, 5 pair, and then that adds up to 9, guaranteed. Again, you can't have a circle be here because then that would just be the same digit and they would be repeat. So they have to go somewhere, so therefore this is a 9 here. So this is 9. Remaining digits in column 1 are 2 and 6. Remaining digits in column 2 are 1, 7, and 8. Okay. So this is interesting. Parts of an arrow are here. This could be the head. This could technically be the head. Either way, if you have 7 or 8 here, and this is the head, obviously that doesn't work. So if you have 7 here, 7 or 8 here, this is the head. This can't add up to whatever, 1 or 2. So if it's not, if this is the head, it's the same problem, right? If this is 7 or 8. You have 1, 7, or 8, and that doesn't add up to 3, 4, 5. If neither of these are the head, that means all 3 of these are the arrow, and you still can't have 7 here. 7, 1, and 3 adds up to a minimum of 11. So this cannot be 7 or 8. It's guaranteed to be 1. Yep, neither of these are the head. That's what I was assuming. These are in 1 to 2 ratios. What out of 3, 4, 5 can be in 1 to 2 ratios? It's only 3 or 4, right? 5, if you have it, you get 2.5, which is not a digit. And 5, if you double it, you get 10, which is not a digit. So this is 3, 4 as a pair, which is in a 1 to 2 ratio with 2, 6, or 8. This can't be 3 or 4 anymore, so this is 5. So the sum of these 3 digits is equal to this. So this is at minimum 1, 1, and 3, which is 5. So this must be at least 6, 7, 8, or 9. Well, we know this 3 is in a 1 to 2 ratio with a 6. So 6 has to be here, which means this can't be 6. So if this were a 1, that would be at minimum at maximum 1, 1, and 4. Which only adds up to 6. So this can never be 1. It's 2 then, which makes this 1. So this has to be 2, 1, and 4 adding up to 7. So this is 3 and 6 then. This could be 4 with 2 or 8. This is a 1 to 2 ratio. It cannot have a 6, so it's either 1, 2, 2, 4, or 4, 8. So it cannot be 1, 2 because that would eliminate all possibilities for this cell there. So it's 2, 4, or 4, 8. Either way, there's a 4 here. So this is 4. This becomes a 2, 8 pair. which eliminates 2 and 8 in the rest of the row. This can't be 2, so this is 6. This can't be 8, so this is 7, which makes this 8, and that makes that 2. Okay. Remaining digits in this box are 1, 3, 5, and 9. Right? This can't be 1, 3, or 9, so this is 5. And this is 1, 3, 9 in some order. Remaining digits in row 7. We have 2, 7, 8. So here, if we have a circle here or a circle here, remaining digits in row 8 are 1, 3, 5, 8, 9. No 8. 1, 3, 5, 9. So 9 can never be on the arrow part of a digit in normal Sudoku unless it's just a single digit. If it adds up with any other digit, obviously it'll add up to 10 at least. So that doesn't work. The circle could be here, or it could extend further. So if the circle is here, then this is at least, this can never be 7, because that would be 7 plus 1 and 2 at minimum, which is 10. If this is the circle, and obviously if it extends further, that's the same problem. So this can't be 7 or 8. If this is a circle, that could work if this is 1, 7, 1. Oh, this is also in a 1 to 2 ratio with another digit. So this can't be 7, period. Okay, so this is 2 or 8. And if it's 8, it doesn't work, right? So if this is a circle, this would be 8, 1, 2 at minimum. If this is 8, that's 11, which is not a single digit. If we try to have the circle here, that's 8, 1, 8, 8, 1, 1 at minimum, which adds up to 10. So that can't be 8 either. So this must be 2. So this is 2, which makes this 1 or 4. 2 cannot be here. 2 cannot be here. 9 cannot be along the arrow. In fact, so again, this can't be another circle here, because if this is a circle here, the problem is that they can't be the same digit because they're in the same box. So it has to extend here or extend here. So that means 7 or 8 must add up with that digit to add up to a single digit. Well, 7 and 3 add up to 10 at minimum. So this has to be a 1. So this is 1, which eliminates 1 here and 1 here. This can't be 1. It's at minimum a 3 because it can't be 2. So it sees 1 and 2 in the column and the row. So if this were 5, this would be at least 2, 3, and 5, which doesn't work. So this must be 2 and 3 here. This can't be 1 or 3 anymore, so this is 9, which eliminates 9 here. This can't be 3 or 9 now, so this is 5. Remaining digits in row 9 are 4, 6, and 9. Well, this is 2 and 3 at least, and this can't be 1, so this can't be 6. It can't be that 5 is already greater than 4, so this must be 9 here, and this is 2, 3, and 4 adding up to it, which makes this a 1. That leaves this as a 4, 6 pair. This 1 plus 7 is 8, and 1 plus 8 is 9, so those are the possibilities in that circle there. Remaining digits in row 4 are 1 through 6, and 1 and 4 cannot be here. So 1 and 4, okay, this is 4, which eliminates 4 here. So this is 5 and 4. 1 and 4 both have to be here in row 4, because it can't be here, they're filled out. Can't be here because of the 1 and 4 in the box. Also, 1 has to be one of these 3. This can't be 4. Okay, we are guaranteed in this upper central box, a 2 is in one of these two cells, which means it's in column 4 or column 5. in this lower central box, we have 2 guaranteed in one of these two cells, which is column 4 and column 5. That means in the rest of column 4 and column 5, you cannot have a 2. So 2 cannot be in any of these cells here. So 2 has to be in one of these cells here. So and it cannot be here because of the 2 in the row. So we're guaranteed a 2 here. Well, 2 is into 1 to 2 ratio only with 1 and 4. Well, 2 can't be here then, because 1 and 4 are only in these spaces, so 2 has to be here. So that's 2, which guarantees this is 1 or 4. This can't be 1, 2, or 3, or 4. This has to be 5 or 6 here. This could add up with one other digit to add up to that digit. So one of these could be the circle. We don't know. So 2 is here. Where is 2 in the remaining in row 4? Cannot be here because they're filled out. Can't be here because of 2 in the box. So it must be one of these two. Okay. Remaining digits in row 6. Well, we're guaranteed 7 has to be one of these two. It's 3, 6, 7, 8, 9. This can't be 6 or 7. This can't be 9 because of 6 or 7 in the column and 9 in the column. Is that helpful? I'm not really sure. Let us see. Do we have anything we can assume here? Not particularly. We are guaranteed one of these two digits is an 8. Because 1 and 7 add up to 8. 1 and 8 add up to 9. So one of these is an 8. I don't know if that's helpful, though. Let's see. What else do we have here? Again, this must be 1 through 6. This must be 1 through 6. Let's just write them all down. 1, 3, 4, 5, 6 here. And 1, 2, 3, 4, 5, 6, but no 1 and 4 here. This cannot be 4. This cannot be 6. Not too helpful. This can't be 5. This can only be 3 through 9. Remaining digits in column 6. Let's try that. 1, 3. No 1. So 3, 4, 6, 7, 8 are the possibilities. No 4 or 8 here. No 6 here. No 7 here. That's not too helpful right now. This digit cannot be 1, 2, 3 or 7, 5, 7, 9. So this is 4, 6, or 8. Okay. This is interesting. So this... Okay, let's see what this is, because everything else has been based off of really the arrows or the black crop key dots. So this is probably similar. This cannot be 1, 2. It could be 3, no 4, 5, no 6, 7, 8. Okay. So obviously it cannot extend past this because this at minimum adds up to 3, 4, and 5 if the circle is past one of these cells. So if it tries to do that, this is 3 at minimum 3 and 4, and then 5. Adding up to 12, which is not allowed in a digit. So one of these is a circle. And none of them can be 9. 9's here, eliminates that possibility for being 9. 9 here eliminates that possibility for being for 9. So if this were 6, it would have to be with 5, which doesn't work. Sorry, if this is 6, it would have to be with 3, which adds up to 9, which doesn't work. So this has to be 5 here. This is 5, therefore this is 3 and 5, adding up to 8. This can no longer be 8 here, no 3 here. These cannot be the same digit, so this must extend like to there at least. I think this has to be 3 and 4 then, right? This can't be 1, 2, 3, 5, 7, 9. If we try to have a 6 here, it could be 6, 3, and 9. So this could, if this is 4, this can't be 6. It would have to be 3. If this is 6, this would have to be 3. If it's 8, it doesn't work. So either way, this is 4 and 6, and this is a 3. So 3, 4 add up to 7. 4, 6, 3 adds up to 9. 3 eliminates 3 in the rest of the column. So this can't be 3, this is 1, which makes this 3. 1 eliminates 1 here, so it's 4, which means this can't be 4 anymore. This can't be 8 anymore because of 8 in the row. Or sorry, 8 in the column. So it's 6, 7 as a pair. 3 eliminates 3 here, so this is 1, which makes this 3. That eliminates 1 here. We have a 4, 6, 4, 6 pair in column 7, which eliminates 4 and 6 in the rest of the column, so they must be 7, 8, 9. 8 can't be either of these cells because of 8's in the row, so this must be an 8 here. This 8 eliminates 8 here, so this is 9, which forces this to be 8 and 7. The 8 and 1 add up to the 9, that's the reason why. This can't be 5 anymore because of 5 in the row. No 5 here. Okay, this can no longer be 9. No 9 there. Whereas 8 in row 6, it must be one of these two cells. Okay, that's not too helpful. This has to be a 7, 9 pair. So this 7, 9 pair here in row 2 eliminates 7, 9 in the rest of the row. So this can't be 7. This is 6, which makes this 7 here. So no 7 here. We have in the central box a 1, 3, 6, 8 quadruplet, which eliminates 1, 3, 6, 8 in the rest of the box. So this must be 5 and 9. That means the rest of row 5 is 3, 6, or 7. Well, 7 can't be here. We have a 3, 6 pair now in row 5, which eliminates 3 and 6 in the rest of the row. So this must be 7 here. Remaining of row 2, we have a 7, 9 pair. So it has to be 1, 2, and 5. Well, this can't be 5, so this is 1 or 2. Which means, where's the 5 in row 2? It has to be here. So this is 5. So I guess the rest we do with just normal Sudoku. Yeah. Okay. This 3 eliminates 3 here. So this is 6. This is 2. That makes that 3. 3 eliminates 3 here. So this is 1. And then that's 6 because of it. 1 eliminates 1 here. So that's 2 and 1. 2 eliminates 2 here, so it's 8 and 2. 8 eliminates 8 here, so it's 3, which means this can't be 3, that's 6, that's 3. And this can't be 3 or 6, it's 8. I guess we have to use this arrow too, so that's not necessarily going, it's not just going to be normal Sudoku. 2 here eliminates 2 here, so this is 1. Last remaining digit here is 8. Where's the 2 in row 1? Can't be here, it must be here. So this is 4, 6 here also. this is 4, 6 here, and it can't be 6 because of 6 in the column. So this is 4, which makes this 6. 3 and 6 add up to 9, which makes this 7, which makes that 9, and the rest is Sudoku. So the 6 eliminates 6 here, so it's 4 and 6, which makes this 4. 9 here eliminates 9 here, so it's 5 and 9. That leaves this as 5 and this as 7. And that's the solution to this. The logic here isn't that hard. You do have to understand somewhat about... You have to really understand arrows, I guess, and black Kropke dots to really get it. But it flows very well. It's a very well set constructed puzzle, I feel. Because all the knowledge of essentially having to have the arrows be certain in certain places. But I don't think that's quite very easy, because you have to actually know a lot about arrows to, well, or be able to deduce a lot about arrows to be able to figure out this fog of war. I don't know. I think I would classify this as easy instead of very easy, but that's just my opinion. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.